Hi, welcome back to Moose in Chemistry. This is Nuclear Chemistry, Types of Nuclear Decay, Lesson 1. All right, let's look at our nuclear symbols first, right here. Our alpha particle can be written as He 4/2 or 4/2 with an alpha symbol, okay? Our beta particles can be written as 0-1e or 0-1 beta, okay? Positron, what a positron is, it's a positive electron. It can be written as 0+1e or 0+1 beta, like that. Okay, a proton is 1/1e for proton, a neutron is 1/0, N with a neutron, and gamma ray is 0 with a gamma symbol. All right, now let's talk about the different types of decay. Alpha decay emission, a 4He nucleus, which is this guy right here, which is called an alpha particle, is removed from the parent atom to change the element into a different element. So our A represents our AMU, and our Z represents our number of protons, which we also call the atomic number. Okay, X is the element name. So here you have the AMU, you're losing a total 4 in the mass, which is okay. And your atomic number right here, you're losing 2 protons to create a new element Y and to release alpha particle. Okay, so again, this AMU is losing 2 protons and 2 neutrons. All right, our beta decay emission is a neutron. It's converted into a proton by changing the element into another element and releasing a beta particle. Again, here's our atomic mass unit, our AMU, and our atomic number, which is the number of protons. That's going to create a brand new element right here, and we're going to be adding a proton to the nucleus by changing a neutron into a proton, and it's going to release our beta particle right here. A positron emission, which is next, and it's an antiparticle to the electron. Same properties as a normal electron, only with a positive charge. Okay, so here's our atomic mass unit, our AMU, and here's our atomic number, which is the number of protons, right? So our AMU is going to stay the same, our element's going to change, and we're actually going to lose a proton here and creating a positron particle. Okay, gamma emissions. Now, gamma emissions take place when an excited nucleus returns to its ground state and releases a high energy photon. So again, here's our AMU, and here's our atomic number, which is the number of protons. So that's why we call it the Z number. Our element stays the same. Our AMU stays the same. Our atomic number stays the same. But we release a photon, which is a high energy particle, and it's a gamma emission. Okay, last but not least is electron capture. An electron from the inner shell of an electron is taken into the nucleus, where it combines with a proton, creating a neutron and a neutrino, which is ejected from the nucleus. The neutrino is ejected, but not the neutron. This process changes the original element into a different element, because when you so here we go, watch what happens. So we have our capturing our electron right here. This is, remember, our AMU. This is our number of protons. So the proton becomes a neutron, so we're actually losing a proton and gaining a neutron. So our mass doesn't really change, but our element changes because we are losing 1 proton. And that will create a new element. Well, that's it for this lesson. You guys be snarly. I will see you back here at Moose in Chemistry.